This is Laura Duncan with CSMS. Today we'll be discussing writing and interpreting absolute value. Remember that graphing patterns of absolute value functions, they are all V-shaped. We start with the parent function, which is oriented around the origin. However, if we have a translation of the function and the plus or minus k is outside of the absolute value bars, and k is greater than 0, that implies that k is positive. And so in that case, the absolute value function would shift up. However, if k is less than 0, that implies that it's negative. So the vertex would shift down, but it would still be a function that opens up. Let's look at a translation to the right and to the left. Notice that if it's translating to the right or to the left, it's inside of the absolute value bars. Now if h is greater than 0, that implies that h is positive. And if h is positive, counterintuitively, it shifts to the left. So the vertex will shift to the left from the parent function. However, if h is less than 0, that's negative, and then the absolute value function would shift to the right. Let's look at a reflection. A reflection of the parent function will reflect over the x-axis. For a is greater than 0, that's the coefficient in front of the absolute value symbol, that implies that a is positive. Well, that just means that it is right side up. However, if a is less than 0, then that implies that it will be reflected. And this is when it will open down. So the first one, we have an open up, and the second one, we have an open down. Now let's look at the vertex. Given a vertex of hk, if the a is positive, that implies that it still opens up, but it has shifted up and to the right. In this case, it will provide a minimum point, so the vertex will be the minimum. However, if a is negative or less than 0, then it will open down and the vertex will then be a maximum point. Let's look at some examples. It says sketch the graph and write an equation to match each transformation, then find each vertex. For the first example, it opens down. I know that means my a is going to be negative, and then it shifts 4 to the left. Remember, if it is talking about moving to the left, that is the one on the inside of the absolute value bar. So we have our y equals, I know my a is going to be negative, and then it shifts to the left, which counterintuitively would be plus 4. This will be a maximum point because if it shifts 4 to the left and it opens down, our function will look like that. Now to find our vertex, notice that we went 4 to the left, so that would be negative 4, and we didn't go up or down any, so that is our vertex. Let's look at our second example. This time it opens up, so my a is going to be positive. It shifts 6 up. I like it when it shifts up because I know that's going to be outside of the absolute value symbol. And it's not counterintuitive. If it shifts up 6 up, it's going to be plus 6. So in this case, we'll go up 6. And since it's a positive a, it will open up. So the vertex is at the point 0.06. Since it opens up, it will be a maximum value. Now let's look at number 3. It opens up, so my A is going to be positive, and then it shifts 7 units to the left. If it shifts 7 units to the left, I know that's going to be inside the absolute value bars, and counterintuitively, it's going to be x plus 7. So now let's graph that. It's going 7 to the left, and it will be opening up. So since it's 7 to the left, my vertex will be -7, 0, and it will be a minimum value. Try number 4 on your own. For number 4, this is the equation. If we shift 9 to the left, then that means I'll shift 9 left and 2 down, and my vertex will be here. Then it will open up, and so I know that that will be a minimum value. Since I shifted 9 left and 2 down, it's going to be -9, -2 is the point of our vertex. Now let's go on to number 5. We're going to write an equation to match each transformation. If it opens down, I know I'm going to have a -a. Then we're going to shift 12 units to the right. Well, this is going to be inside the absolute value, and counterintuitively, it's going to be -12. So that since there's 2 transformations, there are 2 things happening. Let's look at number 6. Opens up. That's not really a transformation from the parent function. It just means my x value, my a value will be positive, so I will have no negative sign outside the absolute value bar. Then it shifts 7 units to the right. So that's going to happen inside of the absolute value bar. Counterintuitively, it's going to be x minus 7. And then the shifting 4 up, that's outside of the absolute value. And this one is just as you think. If it's up, it's positive. Now we're ready to go the opposite way. Now we're going to describe the transformations and write an equation to match each graph. Then we'll find the vertex. So when we're thinking about these, think of the parent function first, which is oriented about the origin. Here's the origin. So one way that it shifted is that it shifted up. It shifted up 6. Now from the origin, did it shift right or left? From the origin, it also shifts right 3. And we see lastly that it will open down. Now let's begin our equation. Remember that you begin with y equals. Since it opens down, it's going to have a negative value outside the absolute value bar. Since it's right 3, that means we're going to have -3. Close the absolute value symbol, and then up 6 means that we'll add 6. So the vertex will be at +3, +6. And because it opens downward, it is a maximum value. Let's look at number 9. A transformation. We can see that it opens up and it's oriented around the origin. So this is the parent function. No transformations happened. So please put a star by this and write down that it is the parent function. Since it's the parent function, it has a vertex of 0, 0, which is a minimum value. and the equation is y equals the absolute value of x. Looking at number 10 from the parent function, which is oriented around 0, 0, it has shifted down 1. Also, it opens downward. Since it opens downward, the equation will have a negative number on the outside of the absolute value bars. And since it shifted down 1, we will subtract 1 outside the absolute value bars. The vertex is at 0, -1, and it is a maximum value. Try number 11 on your own. So let's check number 11. First of all, what you're looking for is the vertex. The vertex you can see is at -1, 3. Match the vertex with your equation. It will be +1 inside the absolute value bars and then +3 outside. That'll just help you check your absolute value function. Now let's interpret an absolute value function. As we interpret this, the roof of a building can be modeled by that function, where x and y are measured in feet and the x-axis represent the base of the roof. First, describe the transformations. We're describing the function, the transformation based on the parent function, y equals the absolute value of x. So you're interpreting what each change means. That change means that it opens down. How about the -7? It's inside the absolute value bars. That means it went right 7. Now the +10 outside of the absolute value bars. That means that we went up 10. Now to graph this function efficiently, we need to determine the vertex. Looking at the equation, since we went right 7, that would be a +7. Since we went up 10, that would be a +10. And since it opens downward, we know that this is going to be a maximum value. So we'll go to our graph. We'll go to the point 7, 10, which is located right here. And then we know the slope is going to be 1 going this way, -1, and the slope will be +1 going this way. Please use your straight edge. Now let's take a look at number 3 so that we can interpret the graph. When we're finding f of 7, that means we're finding when x is equal to 7. There are a couple of ways to do this. If we're finding f of 7, we can simply substitute it into our equation, which was given to us. So we substitute x is equal to 7, and then we solve. So 7 minus 7 is 0. The absolute value of 0 is 0. We can't have a -0. So that means f of 7 is equal to 10. So when x is 7, the y value is equal to 10. I encourage you to go to your graph, and we're looking for when x is equal to 7. When x is equal to 7, that's right here. This point on the function right here demonstrates what we just found mathematically. Now find f of 12. Well, when x is equal to 12, what is the y value? Take some time and substitute it into the formula. Pause the video here. So mathematically, we can see that when x is 12, the y will be equal to 5. Now let's look at number 4. If f of x equals 10, that's talking about our y being equal to 10. So if y is equal to 10, what is the x value? One way we can solve this is to substitute it into our equation and solve from there. But I'd like to encourage you to also use your graph. If y is equal to 10, that's talking about this right here. Which point satisfies that condition? It's this point here. So when y is equal to 10, x would be equal to 7. Now looking at your graph is so important because I want you to look at the second part. If f of x is equal to 8, then that means our y is equal to 8. There are two solutions to this. That's why I want you always going back to the graph. So if y is equal to 8, let's take a look and see which one that is. That would be right here. What are those 2 points? It crosses right there. Let me do that darker. And right here. So when y is equal to 8, let's count. It looks like x is equal to 5 and x is equal to 9. So there are two solutions that we can see. The last thing I'd like to discuss is what this looks like mathematically. So let's substitute 8 into our equation. Now let's begin solving for x. So if we're solving for x, we're going to do the opposite. So we'd have negative 2 equals negative absolute value of 7, x minus 7. And then we're going to divide by this negative 1 to further isolate the x. So we have a value of the absolute value of x minus 7 equals 2. However, the absolute value of x minus 7 can also equal negative 2. That's the nature of absolute value. Because it can equal those two solutions, we can remove the absolute value bars now since we have given both solutions, and now we simply isolate the x by doing the opposite. So that's how we get the solutions mathematically of x equals 9 and x equals 5. That concludes your lesson for today.